Section number 50 is entitled Simplifying Square Roots. One rule you should know is that if you have the square root of a product, you can write it as the product of the square roots. Not only does this equal that, but believe it or not, that equals this. That is, if you have a product, you can split them up. If they are split up, you can write it as a product, the square root of a product. So for example, if you had the square root of 4 times, you have the square root of, say, 450. Well, you might realize this as the square root of 225 times the square root of 2. And you would do that for one reason. You know the square root of 225, but you do not know the square root of 2, nor can you break it down. You must know the numbers in this list, like you know your name. 2 squared is 4, 3 squared is 9, 4 squared is 16. And I meant to say you need to be able to generate the numbers on this list. Nine squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared I don't know, it's 196 I guess. 14 squared is 196. And 15 squared is 225. You know the square roots of all the numbers that are boxed. For example, the square root of 64 is 8. The square root of 100 is 10. You know the square roots of all those numbers. So that is why we break down 450 into 225 and 2. Now, of course, you could have said that 450 is 45 times 10. So the square root of 450 would be the square root of 45 times the square root of 10. This is also correct. But I don't know the square root of 45 and I don't know the square root of 10. And the equal sign is valid, but this didn't help us. Why didn't it help us? Because none of those numbers, 45 nor 10, was on our list. You have to know the list. If I give you the square root of 72, you really shouldn't say 9 times 8. The largest number on our list that goes evenly into 72 is not 64, excuse me, but 36. 36 times 2 is 72. So the square root of 72 is the square root of 36 times the square root of 2. And we know the square root of 36, and we don't know the square root of 2. Nor do we have a number on our list that goes into 2 evenly. Somebody asks you to simplify the square root of 75. You may think, well, 15 times 5 is 75. And you would be correct, absolutely correct. But you can't simplify the square root of 15, and you can't simplify the square root of 5. So you might say, well, there's the answer. Well, just for the record, if this was the answer, you really should write it down as square root of 75. 15 times 5 is 75. But you didn't look at the list if you did it this way. You didn't look at the list. The largest number on our list that goes into 75 is 25. Is 25 times 3. and I know the square root of 75, and I cannot simplify the square root of 3. This is the square root of 25, and this is the square root of 3. Let's try some more. You must know this list on the right, or at least be able to generate it. That's what I always mean when I say know the list. 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, etc. You need to know those numbers. If you were asked to calculate the square root of 300, you should realize 300 as 100 times 3, not 75 times 4, for example. I know the square root of 100 is 10, and the square root of 3, I don't know, nor can I break it down. But I didn't know the square root of 300 either, but I broke it down. You have the square root of 288, and that is being divided by 4. Well, you should, the 4 states, the square root of 288, the largest number on our list that goes into 288 happens to be 144. So 288 is 144 times 2. So the square root of 288, is the square root of 144 times the square root of 2. But we know the square root of 144 is 12. Square root of 2 I don't know, and there's no reason why I wouldn't still divide by 4. And 4 goes into 12 3 times. So the final answer is 3 radical 2, or 3 square root of 2. Now, when it comes to letters, it's pretty straightforward. First, I want you to realize there is an understood 2 right there. There is a 2 right there. You don't see it, but it's understood to be there. It's shorthand notation not to write the 2. Now, how you do these problems is you do long division. You do 2 into that power. 2 goes into 2 one time, remainder 0. You're going to have an x in front, possibly, and an x under the radical, possibly. The whole time that 2 goes into 2 one time, that goes out there, and the remainder goes there. Now, you need to remember that x to the 0 is 1. So the square root of x to the 0 is the square root of 1, which is 1. And this is just x. X to the 1 is x. And x times 1 is x. This is just 1. X times 1 is x. Now, if you had, say, the square root of x to the 7, well, you may have x in front of the radical, and you may have x under the radical. You do 2, the under 2 right there, the understood 2 right there, into 7. 2 into 7 goes 3 times, remainder 1. There's the 3, there's the remainder. X to the 1 is just x. So it's x cubed times the square root of x. X cubed times the square root of x. Long division. That's all it is. It's a lot easier than the numbers. I'd rather do long division where I'm dividing by 2 than have to know the table on the right, when I have to generate the table on the right. If you had the cube root of x to the 6, we do 2 into 6. It goes 3 times, remainder 0. Now if the remainder is 0, or the number in front here is 0, you don't have to write that x. That is, don't write an x underneath the square root sign. Because remember, the number underneath the square root sign is the remainder, and the number in front is the power of the x in front. And x to the 0 is 1, and the square root of 1 is 1. The answer is just x cubed. If somebody asks you to please evaluate or simplify x to the 99, Well, you do 2 into 99. And then we'll go 49 times. 2 times 49 is 98. There's 1 left over. So, x to the 49 times the square root of x to the first power. The first power you don't have to write. It's understood. Okay. What if we have a product of many things underneath the square root sign? Suppose you were asked to simplify, say x to the 7, y to the 6, z to the 12, times w cubed. And again, there's an understood 2 there. So you do 2 into 7. It goes 3 times, remainder 1. That's where the x is. There's a y. The power of y is 6. 2 into 6 goes exactly 3 times with no remainder. And when it comes to z, the power is 12. 2 goes into 12 6 times with no remainder. And when it comes to w, we do 2 into 3 because the power of w is 3. Goes 1 time, remainder 1. So in front, you're going to get x cubed in front of the radical. Y cubed, z to the 6, w to the 1, or just w. And then you're going to have stuff under the radical sign. Then you're going to have stuff under the radical sign. You're going to have x to the 1, or just x. You're going to have y to the 0, which is 1, and I won't bother writing that. Times z to the 0, which again is 1. You don't have to write that. Times w to the 1, or just w. And there's your answer. It's just long division. It is just long division. When I see this type of problem, I think, oh, it's just a long division problem. Just that we put the answers in very strange places. Somebody asks you, say, for the 4th root of x to the 5th, y cubed, z to the 7, w to the 8. Well, we have bases x, y, z, and w. And we do long division. We're dividing by 4. 4 into 5. So 1 time, 1 left over. And we do 4 into the power of y, which is 3. It goes 0 times. Remainder 3. For z, we do 4 into 7. 1 time with 3 left over. For w, we do 4 into 8. Those 2 times, no remainder. So, the answer is going to be x to the 1, or x times y to the 0, which is 1. I won't even write the 1. Times z to the 1, which is z, times w squared. Times x to the 1, which is x, times y cubed, this is all under the radical, times z cubed, times w to the 0, which I won't put. And here is your answer. Here is your answer. If I wrote it down with all the powers, then I know 5 divided by 4 is 1, remainder 1. 3 divided by 4. 3 divided by 4 is 0. So if there's a y to the 0, excuse me. It's 0, remainder is 3. And 7 divided by 4 is 1, remainder is 3. And 8 divided by 4 is 2, remainder is 0. It's just long division. You Okay, you don't need to write down this last line. Long division. And the numbers right here are usually fairly small, like 2 or 3 or 4. You only have 28. If you did, well, then you have to divide by 28. But you'll probably only have 2 anyways. The square root of 7, for example. What's the one thing we know about the square root of 7? By definition, the square root of 7 is that special number that if I multiply it by itself, gives me back 7. That's the definition of square root of 7. The square root of 7 is that special number that if I multiply it by itself, the hint I just did, you get back that number 7. By definition, the square root of 7 times the square root of 7 is 7. The square root of 11 is that special number that if I multiply it by itself, gives me back 11. The square root of a number times the square root of that same number is that number. The square root of x times the square root of x is x. So if I asked you what's the square root of 5x times the square root of 5x, you can say to me, it's 5x. Well, if we know what I just wrote down is 5x, just did it right above, and I multiply it by 3, well then, we'll get 3 times 5x. This is 3, and this times that is 5x. So when you multiply them out, you get 15x. You have the square root of 7x times the square root of 7x divided by 7, you're going to get x back. Because the numerator will just be 7x. And we're dividing by 7. Say by to the 7s and you just get x back. Now, we talked about before how if you have the square root of one thing times another thing, you can separate them. Well, what if you have the square root of a sum? Is this going to equal to the square root of a plus the square root of b? Now, sometimes it will. I mean, after all, if well, yeah. What if b is 0? Well, then, a plus b is just a, if b is 0. B is 0. So then the square root of a plus b is the square root of a plus b, which is the square root of a plus, so b is 0. So the square root of 0 is 0. So yes, the square root of a plus 0 is the square root of a. Sometimes you can break it up, but not usually. Not if one of them is not 0. Not if both of them are non-zero. For example, we know that 25 is equal to 16 plus 9. So the square root of 25 is equal to the square root of 16 plus 9. Nobody's going to argue with that equal sign. And the square root of 25 is 5. The question is this equal to the square root of 16 plus the square root of 9. I don't think anyone would argue that the square root of 16 is 4 plus, and the square root of 9 is 3. And nobody's going to argue with that equal sign. And I doubt very much anyone would debate that 4 plus 3 equals 7. But 5 does not equal 7. One of these equal signs is wrong. It's that one. That is, this didn't make it. The square root of a plus b did not equal to the square root of a plus the square root of b. This would work in subtraction as well. 25 minus 9, I don't think anyone would argue with 16. Hence, the square roots are equal. And square root of 16, we all know is 4. Does it equal the square root of 25 minus the square root of 9? Well, let's see. The square root of 25 is 5 minus, and this is 3. This is 5 minus 3. And that's just what I wrote, that it equals. And 5 minus 3 is 2. Problem is 4 does not equal 2. Sign in the middle is history. The square root of a minus b, the square root of a minus b is not equal to, well, that's a, square root of a minus, that's b, the square root of b. They're not generally equal. They're not generally equal. In fact, the right side can make sense when the left side does not make sense. If you have 9 minus 16, that's the square root of negative 7. That makes no sense. But the right-hand side, the square root of 9 is 3 minus the square root of 16. This makes sense. 3 minus 16 makes sense. Okay, when one side makes sense and the other side makes no sense, they're not equal. If you have a subtraction or an addition underneath the square root sign, you cannot usually break it up. If you're adding, if one of the numbers you're adding is 0, then you can break it up. And you might want to solve this. When is the square root of a plus b equal to the square root of a plus the square root of b? When is that true? Well, you square the left side, you get a plus b. You square the right side, which is the sum. You'll get this squared plus 2 times this times that, which is the square root of ab, plus you'll get that squared, which is b. Okay, and then you take away a from both sides, and you take away positive b from both sides. The left side is 0, the right side is 2 times that. Well, if this times that is 0, and that's 2, well then that must be the 0. Okay, so we have 0 is the square root of ab. Now we square both sides one last time. 0 squared is 0. The right side squared is ab. Well, a equals 0, or b is equal to 0. Okay, that's the only time that equal sign will hold, if a or b is 0. It could have been some other isolated cases as well, but in general, you cannot separate or sum underneath the radical. Just like when you have a product, you were able to separate them into a product of square roots. You can do the same with division. For example, if somebody asked you to evaluate this, whether you write down this next line or not, you have to think it. I write down everything you should think. You should think square root of 36 is 6 divided by the square root of 25 is 5. And I just wrote it down. You want to skip that step? Fine. Now sometimes you might want to do the division. For example, here, you can say here, that's square root of 75 over square root of 3. And the largest number on my list that goes into 75 is 25. So it's the square root of 25 times the square root of 3. Divided by the square root of 3, and that cancels out. And you get square root of 25, which is 5. Or, much easier way, that's the 70s, square root of 75 over 3. 75 over 3 is 25. I did the division first. I actually did that division first. And I know the square root of 25. Okay, a lot simpler. A lot simpler. So why didn't we do it in the case above? The answer is it wouldn't have been simpler. In fact, I don't know any number. 25 doesn't go into 7 to 36 evenly. But it really doesn't have to. If you have 50 over 18, even if I could divide top and bottom by 4, which I can't, but even if I could, I wouldn't. I would divide the top by 2, and I would divide the bottom by 2. Why? Because I know the square root of 25, and I know the square root of 9. And I can make these up all the time. For example, 36 over, what's a good number? I don't want to say 9. I don't want to say 4. Maybe I don't want to say 36. Suppose you have 49 over 25. Multiplied by 4. So you have 196 over, yeah, but both of these are perfect squares. That's the problem. So I mean, if you had 98 over 50, square root of that, if you divided the top by 2 and the bottom by 2, now you have numbers that you know the square root of on top and on the bottom. And that's why I divided by 2 and not, say, by another number. Suppose you had 54 over 96. You have the square root of that. If you divided the top number by 6, you'll get 9. If you divide the bottom number by 6, you'll get 16. And I know the square root of 9, and I know the square root of 4. Okay, sometimes it's friendlier to reduce. Sometimes it's friendlier to reduce. If you didn't want to, you can think of 54. Well, the largest number on our list that goes into 54 is 2, 4, 16, 25, 36. It's going to be 9. I don't know how I skipped 9. Okay, so it's 9 times 6, and the bottom, the largest number that goes into our list, happens to be 16. Goes in 6 times. So you have the square root of 9 times the square root of 6, over the square root of 16 times the square root of 6. I hope you see that canceling out immediately. And here's the square root of 9, and here's the square root of 16. Okay. But if you can see a reduction that helps, then go for it. Thus you have a square root like this. The square root of a to the 6, b to the 7, c to the 4. You divide by b to the 6, e to the 8. Well, this is a long division problem with a, b's, c's, d's, and e's. And there's an understood 2 out here. Well, 2 into 6. It goes evenly 3 times. No radical. That's under the radical. 2 into 7. It goes 3 times, and you have 1 left on the radical. 2 into 4. It goes 2 times evenly. Nothing under the radical. Now we have stuff in the bottom. 2 into 6. It goes 3 times, and nothing under the radical. If there was, it would be in the denominator. How about we have that to the 9? Okay, to the record. Okay. 2 into 8 goes 4 times evenly. Nothing under the radical. 2 into 9, it goes 4 times with the 1 left over. And there's your final answer. If there was no f under the radical, then I would remove the division line. That is, under this radical, I would just have b. I don't need b over blank space. I would just put b underneath there. And there it is. That problem is done. It's just long division. Learn it that way. It's pretty simple. Final answers should not have radicals in the denominator. This is called rationalizing the denominator, getting rid of any radicals in the denominator. So what I want to do is what I just circled is change the way it looks. I don't want it to have radicals in the denominator. That means I'm going to multiply by 1. What would you multiply square root of 3 by to get a non-radical number? The answer is square root of 3. Square root of 3 times square root of 3 is 3. And if what's in this bracket, you shouldn't look anywhere other than in the bracket. And that bracket is going to be 1. And what's that right in the denominator? It goes on the top. And the top will now be a radical 3. And there it is. We rationalize the denominator. The answer does not have a radical in the denominator. If you have 15 over radical 5, we want to change the way it looks. So we multiply by radical 5 over radical 5. That's the type. Radical 5 over radical 5. Because then, when I multiply the bottoms, I get 5. Now when I multiply the tops, I get 15 radical 5. And coincidentally, 5 goes into 15. So there is your final answer. And this completes the section on simplifying square roots.